Let's design a clock signal generator circuit using NE555 or NE556 IC. I needed 2100 Hz minimum frequency and upper level frequency 2700 Hz. So I need to adjust the frequency from 2100 Hz to 2.7 kHz. I used potentiometer here with resistor. Now I can adjust output frequency from 2.1 kHz or 2100 Hz to 2800 Hz. Let's draw the circuit. This is follow-up video for our last session. In that session I shared how to create three-phase signal generator, and now we will create clock signal, because in that video I used XY-PWM module to create clock signal, but now I will use timer IC. We will use NE555 or we will use NE556. It is single timer, this is dual timer. That means this is single IC, and within this IC there are two NE555 timers. Right now I don't have NE555. I will use one section of 556. Let's start. Assalamu alaikum wa rahmatullahi wa barakatuh. I am your host Muhammad Ashraf and I welcome you on my YouTube channel. If you are new to my channel, you can subscribe it. If you want to watch my videos in future, you can press bell icon button, notification for all. NE555 or NE556 or SE556 Timer IC. I am using this 14-pin SE556 IC. Here is cut mark 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Pin number 7 ground, pin 14 VCC. These are common power supply pins for both channels, this one and this one. In this section we have one IC and second IC in this side. So we will use this or this. Pin number 14 VCC, 5 to 18 volt, 15 volt. I will use 5 volt. In last session I used 12 volt, but we can operate this IC at 5 volt because I am planning to use IPM, Intelligent Power Module, and that module which I have, that is TTL logic level. So we will use TTL logic level, so I will use 5 volt power supply. We will connect pin 4, that is reset pin. I will use 5 volt. If you want to use 555 timer, VCC pin will pin number 8, reset same pin number 4. We will connect a resistor between discharge pin and supply pin. In 556, discharge pin is pin number 1. If we are using 555 timer, pin number 7. Red color numbers are for NE555, black color pins are for NE556. It is named RA, and we need another resistor RB. We will connect to pin number 2 and pin number 6, trigger and threshold pins. Threshold pin number 2, while in 555 timer pin number 6. Here pin number 6, in that IC pin number 2. We will make jumper, timing capacitor. So these are timing components 1, 2, 3. We need a proper calculation to take its output frequency. Control pin number 3 here, control pin. We will connect a capacitor 0.01 microfarad or 10 nanofarad capacitor. And if you are using 555 timer, pin number 5. We will take output from pin number 5. If you are using an NE555, output from pin number 3. We will connect pull-up resistor 1 kilo ohm between positive supply and output pin. Now we need to select these components. We can select any value resistor, we can adjust resistor using potentiometers, but it is very hard to adjust capacitance. So we will use fixed value capacitor and we will adjust these values. So pulse duration, duty cycle will be determined by values of these components. A very simple formula for NE556 and NE555, output frequency is 1.44 divided by RA plus 2RB into C. If we see chart in the data sheet, 0.01 microfarad, that is 10 nanofarad. If we use this capacitor and we select approximate range of RA upside resistor 10 kilo ohm, a standard resistor, then we will determine RB. RB will 1.44 required frequency into C minus RA divided by 2. We have a known target for our frequency. This circuit will divide input frequency by 6. I need 350 Hz to 450 Hz output. 350 Hz multiplied by 6. The first required low side frequency is 2100 Hz. If I need 450 Hz multiplied by 6, upside frequency will 2700 Hz. I want to make it variable. If I need just only one frequency, we will select fixed resistors. But now I will use this fixed resistor and we will vary this resistor. RB 1.44 divided by F 2100 into capacitance 10 nanofarad minus 10 kilo ohm, that is this resistor, divided by 2, 29.285 kilo ohm. For this frequency I need 29.285 kilo ohm. We will use a standard value resistor 30 kilo ohm. For other frequency 2700 Hz, I need 21.6 kilo ohm. We will use 20K or 22K. RB, this resistor will now we will use a variable resistor in series with this resistor 20K. 20K plus 10 kilo ohm potentiometer, so it will 30 kilo ohm. Now we will see the output frequency by these values. F 1.44 divided by RA is 10 kilo ohm as we selected, 2 into 20K multiply 10 raised power minus 9, 2880 Hz. If I use 20K resistor, the target frequency will 2880 Hz. It is acceptable. If I use this resistor 30 kilo ohm, the target frequency will 2057 Hz. So this window is now increased. So that's good. I need 2100 Hz and I will receive 2057 Hz. Good. And this window is also good. If we check duty cycle, RB, RA plus 2RB RB, if we have 30 kilo ohm divided by 10 kilo ohm plus 2 into 30 kilo ohm, it will 42.8%. And if we will use 20k resistor, so duty cycle will 40%, so that is acceptable. Because this time we need clock signal, duty cycle is not very important. 10 kilo ohm, 20k, 10 kilo ohm, 0.1 microfarad, 0.1 microfarad. Let's make this circuit. As we discussed, pin number 14 will be connected to positive rail. Pin number 4 will be connected to positive rail. 1, 2, 3, 4. Pin number 7 grounded. In 555 timer, pin number 1 is ground. Here pin number 7. If you are using 555, you will use these red color numbers. I will also create a special video for NE555 timer in detail. We will jumper pin number 2 and 6. This is pin number 6. Here is pin number 2. And we will connect 10 nanofarad capacitor at this pin. It is 10.08. Exact value capacitor is very important to take fixed frequency. We will connect another capacitor at pin number 3. 1, 2, 3. It is also 10 nanofarad capacitor. Ground pin and pin number 3. In this IC, pin number 3 is control pin. In 555 timer, pin number 5 is control pin. And this capacitor at pin number 6 and ground. We will connect 10 kilo ohm resistor between positive supply and pin number 1. Its value is 9.86. This tolerance will also affect on the output frequency. Positive supply and pin number 1. We will use 20 kilo ohm resistor between pin number 1 and 2, addition to 10 kilo ohm potentiometer. This is 10k potentiometer. It is 10.5k. That's also good. So slightly high resistance will create more large window. We will connect a resistor from pin number 1 to the potentiometer. We need 20 kilo ohm resistor. So these are 10k plus 10k from pin number 1 to one end of the potentiometer. Center slider arm will be taken out as output. It will reach to pin number 2. We need another 10 nanofarad capacitor, decoupling capacitor from DC rail, 0.01 microfarad. We will connect RL, load resistor, between positive supply and pin number 5 output pin. So our circuit is ready now. We will connect oscilloscope, pin number 5 and common. Now I will connect power supply, positive and common. 5 volt power supply. When potentiometer is fully counterclockwise, we have 2.083. That is very closer to 2100 Hz. This slight variation in calculation and the practical, that the component tolerance is involved in this calculation. Now we will adjust this potentiometer. 2400 Hz. Perfect. If I want to increase more and more, our required frequency was 2700 and I am receiving 2800 Hz, so we achieved our required target. So this circuit is working good. In upcoming sessions we will combine this circuit with three-phase generator circuit, and then we will connect these both circuits to IPM to take three-phase adjustable signal. So now we will adjust the output frequency using this potentiometer. Duty cycle is also acceptable. If you enjoyed this video, give a thumb up. If you have any question, please write in the comments. If you have not subscribed my channel until now, you can subscribe it.